Hi guys, this is Miss Grenade, and we are doing 4.1, Similar Shapes and Proportions. Our TEK is 7.5a, Proportionality. Generate the critical attributes of similarity. You've done similar figures before, you did that last year, including ratios within and between similar shapes. Our essential question: how can you use ratios? Remember, a ratio is just a fraction, looks like a fraction, to determine if two figures are similar. First, let's review some vocabulary. Fill in your blanks. Similar figures have the same shape, but not the same size. One of them is larger than the other. Polygons are figures made with straight lines. And corresponding angles, that word corresponding, that means that they are in the same position of the two similar figures. I don't know if you did corresponding angles and sides in 6th grade, but I think you probably did. We're going to be using those to determine similarity this year. Okay, here's triangle ABC and triangle DEF. Similar shapes have the same shape but not necessarily the same size. Corresponding angles and corresponding sides of two or more similar shapes are in the same relative position. That just means that angle A is corresponding to angle D because they're in the same position on the two triangles. This symbol, draw this symbol, it's kind of like a little sideways S, means is similar to. In the figure shown, sides and angles that are the same color correspond to each other. This is red. Triangle ABC is similar to triangle DEF. Similar shapes have the same shape, but not necessarily the same size. Corresponding angles and corresponding sides of two or more similar shapes are in the same relative position. This is the same picture that we just looked at, but we're going to use these two triangles to fill in our blanks down here. So corresponding sides are proportional in length. That would mean that if one set of corresponding sides was twice as long as the one in the smaller triangle, all of the corresponding sides would be twice as long. So let's look at line segment AB in the smaller triangle and what line segment is similar to that in the larger triangle. That's right, it would be ED. They have theirs color-coded. It's not color-coded on your worksheet, but it is color-coded here on the PowerPoint. Okay, so which line segment in the small triangle would be similar to EF in the larger triangle? And on the picture here, you can see that they're both green. BC is similar to EF. And so what about AC? That just leaves DF. Both of those are purple. Go TCU Horned Frogs. AC is similar to DF. Corresponding angles are equal in measure. They're the same measure, and you can tell by looking that they're the same measure. Angle A equals, which angle is in the same position in the larger triangle? Here's angle A, and angle D is in the same position. So the symbol for angle is a little angle. Okay, angle B. Now I'm going to put two little arcs right there. And then we're also going to put 2 over here on this E. Do that. Because that shows you, if you're just looking at those, that shows you that because both of these have 2 arcs there, that they are equal to each other. That they are corresponding, so they are equal to each other. Angle B equals angle E, and so that means that angle F, let's put 3 here, it corresponds to angle C. So those are the same measure. Okay, let's look at a new set of triangles. And we're going to try to figure out if the triangles are similar. Check that the corresponding angles of the triangle have equal measures. Okay, so is angle E, see if I can find where my little thing, there we go. Angle E is 106 degrees. So the one that corresponds to that is angle R. Is it also 106? Yes, so write 106 degrees there. Angle E equals angle R. Okay, is angle F equal to angle S? Well, right up here it shows you that angle F is 34 degrees. Angle S is 34 degrees, so those are the same. What about D and Q? D is 40 degrees. What's Q? It's also 40 degrees. So if you answered yes to all 3 of those, all of those are equal to the corresponding angles are equal, then the triangles are similar. We really don't even have to look at the sides to make sure that they are proportional. Okay, how do we know if the side lengths are proportional? We're going to make a fraction that is the short side over the long side for each triangle. And then we check to see if the fractions form a proportion by either simplifying both fractions to see if they simplify to the same thing, or by cross multiplying. And I'm just going to give you a real easy example to write out here. Let's say that in one triangle the short side was 5 and the long side was 10. And in the other triangle the short side was 12 and the long side was 24. What does 5/10 simplify to? Write it right down here. And then what does 12/24 simplify to? Do they simplify to the same thing? They both simplify to 1/2. You know, if you look at a fraction and the top number is half the bottom fraction, if the numerator is half the denominator, then it automatically simplifies to 1/2. So since we know that 12 is half of 24, that automatically simplifies to 1/2. Now, if we chose to, we could cross multiply here and do 24 times 5, and I'm not going to take time to show you, but that equals 120, and 10 times 12 equals 120. So if those cross products are the same, that means the fractions do form a proportion. Remember, a proportion is just 2 fractions that are equal to each other, or 2 ratios that are equal to each other. Okay, so we're going to go back to these, and even though we don't have to do the side lengths to make sure that to see if they are proportional, we're going to, so I can show you how that works. So first we're going to make a fraction for triangle DEF. Remember, we're going to do short side over long side. So the short side is 7 and the long side is 12. So let's make that fraction 7/12. Okay, you do the one for triangle QRS. Write the fraction for the short side over the long side for QRS. Okay, 21 is the shortest one and 36 is the longest one. 21 over 36. Now, will 7/12 simplify? If it does, simplify it. If it doesn't, leave it. Does 21/36 simplify? If it does, simplify. If it doesn't, leave it. Now, 7/12 will not simplify. That is lowest terms. But if you look at 21 and 36, both of those the numerator and the denominator both, we'll divide by 3. 3 goes into 21 7 times, and 3 goes into 36 12 times. So what do you notice about these two fractions? They are equal. So that means that these two triangles are similar according to side lengths. The side lengths are proportional. Now another way you can do that is to cross multiply. So if we took 7/12 and 21/36, which we're not going to take time to do, I'm just going to tell you. 12 times 21 is 252, and 36 times 7 is also 252. Unless these numbers are smaller, it's easier to do the simplifying way, I think. But you can do it either way. If neither fraction will simplify, and they're not the same thing, then your triangles are not similar. Okay, let's go on. Explain whether the triangles are similar. So now it's your turn to try. So I'm going to read these questions, and I want you to answer them before I put the answers down. Can I trust you to do that? Okay, number 2. We're going to do number 2 first. Are the corresponding angles equal? So we know that angle B is 27 degrees. Which angle is corresponding to angle B in the big triangle? It's E. Does 27 equal 29? Nope. Angle A is 54. Angle D is corresponding. 54 and 49 don't equal each other. Angle C is 99. Angle F is 102. Those don't equal each other. So no, the corresponding angles are not equal. So does that mean the triangles are or are not similar? Which one? They are not similar. If the corresponding angles are not equal, your triangles are not similar. You don't have to go any farther than that. Do we also need to check to see if the corresponding sides are proportional? No, we don't. Why not? It's because the angles are not equal. That symbol means are not equal. Okay, now let's go on to number 3. Now you might notice something on number 3 here. These aren't going the same direction. So it's a little harder to tell which ones are corresponding to each other. When I'm doing one like this, I flip one of them over so that they're both going the same direction. So I would flip this one over, this smaller one over, and redraw it. Maybe yours is a little better than mine. And then this would be B, and this would be A, and this would be C. Okay, so angle B corresponds to angle E. And angle E is 129. Is angle B 129? Yep, it is. But we've got to check the other two also, because if all 3 of them are equal, then we don't have similar triangles. Okay, angle D is 33 degrees, and angle D corresponds to angle A. Is angle A 33 degrees? Yes, it is. And angle C corresponds to angle F. And both of those are 18 degrees. So are the corresponding angles equal? Yes. So the triangles are similar. And we're also going to prove they're similar using the fraction to determine proportionality of side lengths. Okay. We're just working on number 3 here because it's the one that's similar. So we're not working with these right now. So right now put me on pause and make the fraction for short over long for both triangle ABC and triangle DEF. Put it on pause right now and do that. Okay, triangle ABC, 4/10. Triangle DEF, 16/40. Simplify both fractions. So since both of these are even, the numerator and denominator will both divide by 2, giving us 2/5. What's the largest number you can put into both 16 and 40? How about 8? And you know what? You don't have to divide by 8 the first time to simplify. You could have divided by 2 the first time. As long as you keep going till you get to lowest terms. See, they simplify to the same thing. So that proves that they are similar. If we cross multiplied, 10 times 16 is 160. 40 times 4 is 160. Now some of you may have noticed something else, which I haven't mentioned yet. What do you notice about going from the smaller one to the larger one here? Is there a scale factor here that you can multiply by? Oh, see, here I go again. 4 times 4 is 16, and 10 times 4 is 40. So when you can use that scale factor and multiply by the same thing, that also means that they are similar. Oh, I forgot to answer this. Are the cross products equal? Yes. Okay, now we're going to look at some trapezoids to see if they are similar. No, actually, first we're going to do some triangles. First, we're going to draw the two triangles. It says there's a rectangle ABCD with sides of 7 and 5. So draw a rectangle out here. A, B, C, D. 7 goes on the long side, 5 goes on the short side. And rectangle MNOP, it's a bigger one, so it doesn't have to be to scale. Just draw a bigger one. MNOP with side lengths of 21 and 15. So 21 and 15. We know that in rectangles, all angles measure, what do they measure? They're all the same. They're all 90 degrees. They are right angles. So that really doesn't help us. Because just because they are all 90 degrees, that doesn't mean that they are similar. Because look here, we could have a triangle that looks like, a rectangle that looks like this, and a rectangle that looks like this. Those aren't similar. This one's short and squatty, and this one's more square-like. So we have to do the fractions. So let's do 5/7, short over long, and let's do 15/21, short over long. What do you notice about these two? Anything? How about 5 times 3 is 15, and 7 times 3 is 21? Or if we simplified it, we could divide both of these by 3, and we would get 5/7. So when they simplify to the same thing, or you've got that scale factor you can multiply by, that means that your rectangles are similar. So these two are similar. Now let's go on to number 4 and look at the trapezoids. Do the corresponding angles have equal measures? So look at this. Look at the small one. So 46 and 46, those match up. 54 and 54, those match up. 110 and 110, those match up. And I don't have room for 4, but 150 and 150, those match up. So yeah, they do. Does that mean what are these called? I said it and I wasn't supposed to. How about trapezoids? Well, it meant that they were similar when we had triangles. Do these look similar? They don't even look similar. This one's more, I don't know, kind of squarish. It's not a square, but it's kind of squarish, and this one's longer like a rectangle. So they don't even look similar to each other. Now, that's not always the key. Sometimes they do look similar and they're not, but these don't even look similar. So let's do the fractions to see if the side lengths are proportional. So make your fractions. Remember, we're doing, even though we've got 4 numbers here, we're still doing short over long. So we've got 3 over 8 for this one, 3 over 8. And then this one is 6 and 48. Okay, does 3/8 simplify? No. Does 6/48 simplify? Yes. What's the biggest number you can divide both of these by? They're both even, so we could divide by 2. The biggest number we can divide by is 6. So that means 6 divided by 6 is 1. 48 divided by 6 is 8. So are our fractions equal to each other when you simplify? No, they are not. So that means that those trapezoids are not similar. Okay, I think this was a little long. Sorry about that. But now do the problems on the Google Doc and hit submit.